This is an example of application of empirical rule. A study conducted on the birth weights of 678 babies born in New York with the mean weight 2956 grams and the standard deviation 835 grams. And assume that the birth weight data are approximately bell-shaped. We need to estimate the number of newborns whose weight was less than 4626 grams. Since the data are approximately bell-shaped, we can apply the empirical rule. Mu is 2956. This value 4626, that is a number bigger than this, so it will be definitely on the right side of mu. So first we will see how many standard deviation away is this number from mu. So we will find z, that is x minus mu divided by sigma, that is x is 4626 minus mu is 2956 divided by sigma is 835. So that is equal to, this value is actually 2 standard deviation away from mu. That means 2956 plus 2 times sigma, like 835, that is equal 4626. So mu plus 2 times sigma is this value. And from the empirical rule, we know that 95% of the data falls within 2 standard deviation of the mean. Since this is saying less than this value, so that is 95%, and there is a small percent here too, so we need to calculate that. Sum of these two areas will be 5%, because the total is, we are seeing this total is 100%. So if this is 95%, the remaining will be 5%. So this is just the half of that. So this will be 5% divided by 2, that is 2.5%. So 2.5% plus 95%, that is 97.5% of the newborns weigh less than 4626 grams. Now find the 97.5% of the total newborns. Convert the percent into decimal, that by moving the decimal 2 decimal places to left and multiply with this. We can conclude that approximately 661 of 678 newborns weighed less than 4626 grams. Let's look at another example. We need to estimate the number of newborns whose weight was greater than 2121 grams. First we will find out this value, how many standard deviation away from the mean. Since it is equal -1, that means it is mu plus -1 times sigma, or it is actually left side. This is mu, this value, mu minus sigma is this value. And now we need to calculate the number of newborns whose weight is greater than this value. Greater than means right side of this, so this one. First we will find out how many percent is greater than this value. So by empirical rule, we know that 68% of the newborn is within mu minus sigma and mu plus sigma. So this is 68%. Now we need to find this percent. Since the total is 100%, sum of these areas will be 100 minus 68, that is 32. So this area will be 32 divided by 2, because sum of these two are 32. So this will be half of 32. that is 16%. So the total area will be 68 plus 16, that is 84%. Approximately 84% of the newborn weight greater than 2121 grams. Now estimate the number of newborns. Find the 84% of the total number of babies. We can conclude that approximately 569 or 570 newborns weighed more than 2121 grams. Now look at another example. In this one, we need to estimate the number of newborns whose weight was between 2956 and 3791 grams. So this is actually mu. Now we need to find out this value, how many standard deviation away from the mean. So since this is greater than, it will be above the mean. Since z is 1, we can see that this value is 1 standard deviation above this mean. That means that value is here. By empirical rule, 68% of the data is between mu minus sigma and mu plus sigma. Since this is symmetric, this is bell shape and this is symmetric, half of 68%, that means 34% of the data will be between mu and mu plus sigma. Now find the 34% of the total newborns, and we can conclude that approximately 230 or 231 of 678 newborns weighed between these two values.